Hey, welcome back to your favorite Fundamentals of College Math class. We're going to look at compound interest today. And here's our objectives. We'll begin with a discussion of compound interest. So that's the interest computed on the original principal as well as any accumulated interest. So I'm going to give you an example here. Let's say you put $10,000 and earn in as your principal into some investment. You earn $10,000 each year for 3 years. The interest is paid out once a year. So how much money would you have at the end of the 3 years? So let's do for the end of year one. You have the amount you have is the principal plus the interest. All right, so you have the $10,000 plus the interest you made. Remember, you're making 10% on $10,000. So 10%, 0.10 times 10,000 is $1,000 in interest, right? I'm just using the old simple interest formula here. 10,000 bucks, 0.10 times a year is 10,000 times 0.10 is 1,000. That's where I get that 1,000. So you end up with, after 1 year, you have $11,000. Okay. Now year two comes along and you're still going to make 10% on that. So you have $11,000. And then 10% of $11,000 or 0.10 times 11,000 is 1,100. So you end up with $12,100 at the end of year two. At the end of year three, so now you're going into year three and you have $12,100 in principal and you make 10% on that $12,100. So 10% of 12,100 is 1,210, 1210. So at the end of year three, you now have $13,310. Again, this is considering you making 10% every year. You're leaving your money in to gain interest, or to accumulate interest on your principal as well as on any interest. This is called compound interest, right? So you end up with $13,310 when you only invested originally $10,000 right there, right? 10,000 bucks. So you made $3,310 all in compound interest, right? Free money. So this is what rich people understand. If you want to be rich, you definitely want to listen to this section, because with compound interest, what happens is your money, instead of just growing linearly, your money grows exponentially. Okay? That is the magic of compound interest. That is what all rich people understand and why they invest their money. Okay, so with compound interest, you have a little different formula here. So this is our formula to find the accumulated amount. So A is our future value, so that's how much we end up with. P is our principal or our present value, the principal amount that we put in at the beginning. R is the interest rate. This is as a decimal though. So if it's 8%, you'd want to put in 0.08. Now you see this N, right? These two N's. The N's, that's how many compoundings. N compoundings per year. So for example, if you put your money into an investment and they say that we'll pay you interest once a year on it, that's annually, then your N would be 1. If they say we're going to pay you interest semi-annually, then your N would be 2. If they say we're going to give you quarterly payments, that'd be 4 times a year. Monthly, this is what you're going to see in like your savings accounts from banks. They say, hey, we're going to kick you out a little bit of interest monthly, so 12 times a year. You might see weekly, then your N would be 52. You might see daily, N would be 365 and so on. So they give you a tiny bit of interest every day, right? So that's the N. Now finally the T right there is T is time in years. Okay, so we're going to use this formula. Here's an example. So let's do the one that we just did. We invest $10,000. There's our principal amount, our present value. We put $10,000 into our investment. 1 plus, now what's our interest rate? 10%, so 0.10. And it's compounded, so they're paying only once per year at the end of the year, right? So the interest is paid annually, so N equals 1, just once per year. So 1 there. Up here, there's a, where that N is, there's a 1. And then our time T in years at the end of 3 years. So our time is 3 right here. So then we got 10,000, 1 plus, we go ahead and do this division first. 0.10 divided by 1 is 0.10. And then we got 1 times 3, we got 3 up here. So we got 10,000 times 1.10. Remember, please excuse my dear Aunt Sally, parentheses, do the parentheses first. And then we do the exponent, and then multiplication, division, left or right, and addition, subtraction. So you want to work from the inside out. So you do that division inside the parentheses, and then you do the addition. So again, you're simplifying your parentheses first. So you got 1.1, and then you're going to take it to the third power, 10,000 times, and then you get your calculator, 1.10 to the third, and you get 1.331, and then you multiply it by 10,000, and you get that 13,310. So see how we can do that much easier with that formula? Just punch it into the formula. And so you want to use that formula here on these examples. Let's do another one here. You deposit $2,000 in a savings account. So we're putting $2,000 in. That's our present value. That's our principal amount that we're putting in. Has a rate of 6%, so 0.06 on the interest rate. Now, how many compoundings per year? It says annually. So each year they're giving you, so once per year is how often they kick out the interest. So both ends are 1, and then T time in years. It's like we're doing this for 3 years. What's the account balance at the end of 3 years? So again, do the division first. 0.06 divided by 1. 1 times 3 is 3. Add those up. Make sure you do that next. The exponent there, 1.06 to the third, which is 1.191016 times the 2,000 is 2382.03. So that's how much you have at the end. Now, part B says find the interest. So the interest is what you end up with minus your principal. So 2382.03 is how much our investment was worth. Minus, we started with $2,000. So $382.03 was all free interest. 382.03. Okay. Now make sure when you're doing this, don't round it until the very end, right? So don't, in other words, like with this 1.06 to the third, don't cut this off to like 1.2. You have the whole thing, you got to have the whole thing in your calculator and then multiply it by the 2,000 up there. And then you round it at the very end, that's it, okay? Because this is in dollars, so you want to round it to the nearest hundredth, okay? All right, how about this one? deposit $7,500 in a savings account that has a rate of 6%. The interest is now it's compounded monthly. So we're putting 7,500 in. The interest rate's 6%, so 0.06, but this is compound monthly. So 12 times a year, so 12 for your N, and we're doing this for 5 years. Okay. I'm going to go 0.06 divided by 12, I get 0.005 plus the 1, so 1.005. And then to the 12 times 5, that's 60 up there. So now I go 1.005 to the 60th power, and I get 1.348850153, anyway, blah, blah, blah. And now multiply that by 7,500 in front, and I get 10,116.37614. Now I can round it to the nearest hundredth, so to that position. Now, so I'm looking at the 6 to the right of the 7. 6 means, hey, bump that up to 38. So the account balance is 10,116.38. That's how much money you're going to have after 5 years. That's part A. All right, part B. What's the interest? Well, the interest, how much free money did I have? Well, I ended up with 10,116.38, and I started with only $7,500. So if I subtract those two, I get 2,616.38, all in free money. 5 years of earning money with compound interest at 6%. I get $2,616.38. All right. Now I'm going to show you how to do this with a financial calculator, this exact same problem, okay? So I want you to play with the formulas. Some students really like the formulas. The formulas are wonderful if you have just a basic calculator, but you can also download a financial calculator, and it's not a bad idea to learn how to use a financial calculator. So if you go ahead and search financial calculator on your phone, this is on my phone, my Android phone. My Samsung, and you'll see this is the one I want you to download right there by that BC News or whatever that is. Okay, that's the one I want you to download onto your phone. Now, since I can't show my phone on this screen that I have the screen recorder for, I'm gonna have to use this website. Okay, that's the similar website for them. So I'll show you how to do this problem using the website. Whoops. So I'm going to go to fncalculator.com, and I'm going to do this problem right here. Deposit 7,500 bucks. So here, let me pull up my. Okay, now when you go to fncalculator.com right here, go ahead and click on the time value of money calculator right there. Time value of money calculator, right? And you can see, and if you're using your phone, you can just use your phone for this. Again, you should see that little image right there for downloading. Now, this question said you're depositing $7,500. Okay, so your present value, the initial amount, is 7,500 bucks. We're not making any payments. Okay, don't worry about that in this section. We'll talk about making payments and stuff in a future section and when we do mortgages and so on. So don't worry about that. You leave that as 0. The future value is what we're trying to figure out, right? What's the account balance, the capital A, if you will, right there. Our interest rate is 6%. The periods. So how many periods do we have? This is N times T. Okay, so N times T. In other words, we're doing this 5, you're compounding this thing, or how many interest payments you're going to get. 5 years times 12. So 5 times 12 is 60. So this is n times t. Okay, that's the exponent on that formula. Now the question is, how often are we doing this? This is compounded monthly. If it was n being 1, I'd put annually. If they said quarterly, I'd put the quarterly in. This one, n is 12. And now what I'm going to do here is I'm going to click on future value. Click on future value. There it is, 10116.38. Now notice the negative there. You can ignore that. It's part of the programming. We'll kind of talk about that more when we do like mortgages and stuff. But your present value and your future value are going to have differing signs. Okay, but this is a positive amount. You're not in debt. You've accumulated 10116.3 out. It's like this is what you put in, so this is your payout, right? It's opposite that is your payout, right? Because it costed that much money to put in. In fact, if you'd have put negative 7,500 in, clicked on as positive. In other words, you're paying in 7,500, negative paying in, and it's kicking out positive 10116.38 in investments, okay? But I just leave it like that, positive kicks out 10116.38. Okay, so that's how you use the financial calculator. When I do that, I'm going to write those. So let me continue on here. These use again. Use your. So put in the 7,500. Payment 0, and the future value is the one that you're going to click. Okay. All right, continuous compounding. So for continuous compounding, you have a different formula. A equals PE to the RT. So let's do some problems where we're comparing situations here. You decide to invest $8,000 for 6 years. And you have a choice between two accounts. The first pays 7% compound and monthly. So is the compound monthly a good deal? Well, let's find out how much this will pay out. So if you're using the formula, you say I'm putting in $8,000 at 7% compounded monthly for 6 years. And this ends up being, let's see here, 12,160.84. Now, if you're doing it with the calculator, present value, payment, future value, interest rate. This is not as a decimal, so on the interest rate, you just put in 7% there, not 0.07. Let's see, interest rate, you've also got your periods. I almost forgot what the next one was. Periods, and then compounding. Okay, so this is compound monthly, so we know it's 12 here. Periods, again, the periods here are n times t, so it's 12 times 6 years. So you got to put 72 in for the periods here. Okay, it's an upfront investment of $8,000. I told you we're not making any monthly payments on this. I'm going to click future value, and it'll spit out, when I click that, it'll spit out negative 12,160.84. So again, you have 12,160.84. All right, now let's do the compounding continuously. So A equals PE to the RT. So is this a better deal if it compounds continuously? We're putting in $8,000. E, you need to have a scientific calculator for this. E is the exponential. R is the interest rate, so 0.07. T is your time in years, and so we're doing this again for 6 years. So this ends up being here let's see if I got 0.0, oh, I'm sorry, good grief. This one's paying, the second one's only paying 6.85%. So $8,000 e to the 0.0685 for 6 years. So 0.0685, so I get $8,000 e to the, I'm going to go ahead and multiply those two and I get 0.411. Now I'm going to take e to that power, and that gives me 1.58083253, anyway, blah, blah, blah. This keeps going. Don't round this. Go ahead and just use that answer and multiply it by the 8,000 in front, and you get 12,066.60. You can round it at the end again. Don't want to have rounding error. So the question is, which one was more? A compound, if I have a continuous compounding, in other words, it's gaining interest every day of every second, but it's only at 6.85%. Is that better than a compound monthly situation at 7%? Well, it looks like we end up with a little bit more over here, just under $100 more. So I'm going to go with the monthly compound situation here. And by the way, a continuous compounding is really more theoretical. I've never seen an investment product have continuous compounding. All right, if we're calculating present value, if you take this formula, you just divide both sides by that. Then you're end up with this. So it's not a new formula. So I'm just going to use the old formula when I do these. How much money should be deposited? In other words, what's the P? What's the P? Question mark, right? If you're earning 6%, so I'm solving for P, I'm earning 6% compounded monthly, so my N is 12 times per year. My T, 5 years, and because I want to accumulate $20,000. I want to accumulate $20,000. Well, 0.06 divided by 12 is 0.005, and then I add it to the 1, so I got 1.005 to the 60. So now I take it to the 60th power. I got 1.34885015, blah, blah, blah. 20,000 over here. And again, we're solving for P. So I could divide both sides by 1.34885015. This side by 1.34888515. And then I'll have P. So my P is, once I divide that, 14,827.44. So I got to put up front, if I want to have $20,000 in 5 years at 6% compounded monthly, I got to put in 14,827.44 up front. If I think I can get 6% per year on this investment. All right. Now, if you're doing it with a calculator, present value, payment, future value, rate, periods, compounding. Well, we know this is monthly, so 12. Our periods is n times t, so 12 times 5, so I got 60. I'm going to get an interest rate of 6%, so you just leave it as 6. I know my future value, present value, they have opposite signs, but I want to end up with $20,000 and make that negative. So negative $20,000, my payment's 0, I'm not making any payments. I'm going to click present value, and it'll spit that answer out. When I click that, it'll spit out what I want, 14,827.44. Okay, when I do that on the calculator. Okay, I'll show you that real quick here. Pull this up. So I want to end up with $20,000. I'm doing this at 6% and monthly compounds 12 times per year. 12 times 5 is 60. 14,827.44. Just like that. Okay. All right. Last concept, annual yield, is a simple interest rate that produces. Here is the simple interest. What's the equivalent simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at stated rate? So, for example, let's think about it this way. You deposit 4,000 in an account, pays 8% compounded monthly. Okay. What's the future value? So you put 4p 1 plus r over n to the nt. How much do you have if you put 4,000 in at 8% compounded monthly for 1 year? Okay, and this ends up being 4332. If you do it with a financial calculator, you're putting in $4,000. You're making no payments. You're going to solve for the future value. Your rate is 8%. Your periods, n times t, so n is 12 times 1. 1 year is 12 times 1 is 12. And your compounding is monthly. You click that and you'll get the negative 4332. So 4332, okay? That's how much you end up with. So part B says, use a future value formula for simple interest to determine the effective annual yield. In other words, this investment, what's happening here is every month they're kicking you out a little bit of interest, right? Because you end up with 4332. You only started with 4,000. So $332. So you're getting about, 27 something each month, and of course that's growing a little bit more than that each month to get the 4332 at the end. In other words, $332 in free money. What's the equivalent simple interest rate? So if you remember from last section, we had the principal plus the interest. So if I ended up with 4332, and this is P plus PRT. Remember, interest is principal times rate times time. So we have 4332 is 4,000 plus 4,000. What's the R? I don't know what this effective annual yield is, but I'm only doing this for 1 year. So 4,000 times 1 times R is 4,000 R. Now you're just doing the algebra here. Subtract 4,000 both sides. So you get 332 equals 4,000 R. Divide by 4,000. And your effective annual yield is 0.083. So 8.3%. So this is saying, if I was to invest the money and only have it kick out interest at the end of the year, compounded annually, like a simple interest situation, I would have to get 8.3% to have 332 free dollars. But if I just get 8% and I'm compounded monthly, I'm going to get the same amount of free money. Okay. Again, this is the effective annual yield. And there's actually a formula for it. So here's the formula for the effective annual yield. So you can say, instead of going through all that, why don't we just plug it in? 1 plus, it's at 0.08. If I was to invest this 0.08 at a compounded monthly situation to a 12 up here, I would get This 0.08 divided by 12 is 0.006 repeated. So 1.006, again, the 6 is repeated. And this is 1.082999950. So anyways, and subtract the 1, 0.08299. Again, don't make sure you don't round to the very, very end. So it's about 0.083 or 8.3%. That's the effective annual yield. Okay, so you can just use that formula if you'd like to. Either way will work. Okay, thank you so much for listening. We'll see you guys next time.